Hello, in this video I'm going to look at finding the trig functions of the angle measure negative 2,850 degrees. Okay, so the first place I need to start on this is, where am I? Like, where is negative 2,850 degrees? I have no idea where I'm at. It's not something I'm familiar with. So you've got to convert it to a coterminal angle, so basically an angle in the same location but with a different rotation to get to that location, right? And the way you do that is you add or subtract full revolutions. Okay? So that's what I'm going to do. Now, let me do it a couple ways so you kind of see this. So let's suppose I start at negative 2,850 degrees, and I understand that that's degrees. I'm just putting that in my calculator. And remember, one revolution, let's go back and make sure we got this. One revolution is equal to 360 degrees. Meaning that if I'm at a particular location, like here, and I go 360 degrees, guess where I end up? At exactly the same place. That's the idea. Or it could go in the other direction, right? But guess what? It's one revolution and I end up at exactly the same place. So, but it'll have a different name for that location because I'd either be adding another 360 degrees or subtracting another 360 degrees. So let's say they start me here at negative 2,850 degrees and I add 360. Do I recognize that? Nope. So add another 360. Now, why am I adding? Because I don't know negative angles very well. In fact, what are the degree measures that I do know? The ones from 0 to 360. Those are the ones I know. So I keep adding 360, getting closer until I get to something I recognize. Getting closer. Bam. I know 30 degrees. That I'm familiar with. I even know the XY coordinates for it because I know the unit circle. All right? That's the idea. Now, I did this the long, hard way to show you what I kept doing is basically adding full revolutions. Is there an easier way? Of course. Right? So what you could do is say, how many sets of 360 degrees, or how many revolutions, full revolutions, are there in 2,850 degrees, be it positive or negative, that I can basically back out. So if I take 2,850 degrees, right, and I divide, and I say divided by 360, then what I get .91. So 7 revolutions and then some. But remember, I'm starting out with actually a negative number, right? So technically, I've got a negative revolution. So if I say, okay, I'm going to take negative 2,850 degrees, and I'm going to add 7 revolutions of 360 in the positive direction, right? My cats are having the friskies. I end up at negative 330 degrees, and then I'm like, well, I still don't, that's closer. I kind of know where that is because it's, at least it's between 0 and 360. It's just in the negative direction. So I'm going to add another 360, and there I am at 30. So you could have added 8 revolutions, right? So I'm just showing you different little ways of getting there, but the idea is this. We're at this location that we know of, right? One way we got there was by doing, I think it was starting here and going, let's see here, 2,950 divided by 360, we said was what, 7.9. Okay, so basically another way of saying this is going 1, 2, 3, 4, 5, 6, 7, and then that almost 8 revolutions, but the 0.9, whatever revolutions, right? That's one way we got there. The other way we could get there is just by going like this, 30 degrees, right? So, or the other way we could get there is by going, starting, so we're always starting at 0. Sorry, let me start that. Notice here I started at 0 and I went, negative 7, and then 0.9 something revolutions. Or we'd start at 0 and went positive 30. Or we could go starting at 0, and go negative 330 degrees. Guess what? They all end up where? Here, right? So it's the same location, it's just different ways of getting there because of different revolutions. So that was the way to figure out where you're at, okay? Now that we know where we're at, and working with negative 2,850 degrees is the same as working with the xy coordinates of 30 degrees, right, which is square root of 3 over 2 in the x direction and positive 1/2 in the y direction. I can work with that. So working with the xy coordinates of the 30 degrees is the same as working with the xy coordinates of negative 2,850 degrees. Now, they ask us now to find the 6 trig functions of that. And hopefully this should be in your memory. All right, here's cosine, sine, tangent, and then of course you got the reciprocals, secant, cosecant, and cotangent. Now, let me give you a little blurb. I think I've put this in another video, but Daniel Willingham is a cognitive psychologist who talks about working memory versus long-term memory when you're learning. So I have a lot of students that'll tell me, well, I can just look it up. Right? I can look up these definitions. Yeah, you can. But the problem is this. Have you been sitting in a class and, you know, you're listening and working, and pretty soon you feel like your head's going to explode, like you're on overload. You just can't take any more. Well, that's where your working memory is too full. It literally is too full to go any further. So what you want to do is increase the working memory as much as possible, the part that's learning new stuff. How do you do that? You know these and have these in long-term memory and don't have to move them into working memory to be able to work with them. So that's the idea. The more you memorize and have this in long-term memory, the faster and easier it is to learn new stuff that's associated with this. Anyway, that's my 2 cents, which is really Daniel Willingham's 2 cents. All right, from here then, let's say I take a look at cosine of 30 degrees. By definition, it's x over r, and this is the unit circle where the radius is a length of 1, so r is 1. So basically I'm just looking at the x coordinate, so that's square root 3 over 2. I'm looking at the sine of 30 degrees, which is y over r, but in this case it's just y because we're on the unit circle, and that's 1/2. And now we're going to be doing some arithmetic, and here's where I wanted to just get, hopefully, to every jot and tittle so that you can see all the rationalizations and all that. So let's look at tangent of 30 degrees. Definition is, you should know it, y over x. So y is 1/2, x is 3/2, so that's 1/2 divided by square root 3 over 2, okay? Now, let me kind of remind you, if you recall, let's do something a little simpler. Let's say you had the fraction 1/2 divided by 2/5, where you don't have a root in there, right? The rule is there's different ways of saying it, but I've learned flip and multiply. So you take the denominator, you flip it, so you have 1/2, and then you multiply, so 5/2, right? Is that right? Yeah, 5/2, yeah. So then you flip it, so instead of 2/5, it becomes 5/2, and then you multiply across. So you get 5 times 1 is 5, 2 times 2 is 4. Now, that's the flip and multiply. I've heard students say it other ways. It's the same idea, though. I'm sure once we went through it, you're like, oh yeah, I'm right. I just want to show you what this really is. It's the use of the multiplicative inverse. So when the multiplicative inverse is where if you multiply something times 1, it's still itself, like how many times you have it, once, itself. So here, when I have 1/2 times divided by 2/5, what I'm really doing is I'm going to multiply by 1. So I'm not changing the value, I'm changing the form, but what I'm going to do is pick the 1 in such a way that I strategically cancel the denominator. So what would be the multiplicative inverse of 2/5? It would be 5/2. But what I do to the denominator, I must do to the numerator, otherwise I'm not really multiplying by 1. So 5/2 divided by 5/2 is 1. But look, watch what happens. When I multiply across, the 5's cancel out, the 2's cancel out. And now I multiply across here and I get 1 times 5 is 5, 2 times 2 is 4, which is what we got up here, right? So I just wanted to make sure you understood that. So that's what you do there for when you have a fraction over a fraction. So now going back to this problem, where you have the tangent of 30 degrees is y over x. So here I need to say, oh, well, it's 1/2 times, now flip, right, and multiply 2 over square root 3. The 2's cancel out and I get 1 over square root 3. And the books and software programs require that you rationalize the denominator. So that means I need to take this 1 over square root 3 and multiply again by 1, but in a way that you don't have a root or radical in the denominator. So I'm going to multiply by square root 3 over square root 3. So that's 1. I'm not changing the value, changing the form only. So you'll have 1 times square root 3 is square root 3, and then square root 3 times square root 3 is 3. So basically the tangent of 30 degrees is square root 3 over 3. Okay. So now we go to the reciprocals. All right. So let's go ahead and look at cosine. The reciprocal of cosine would be 2 over square root 3. All right. So secant of 30 degrees is r over y, which in our case is 1 over square root 3 over 2. Flip and multiply, you get 2 over square root 3. But we don't like that, so we have to rationalize the denominator by multiplying by 1 here. Square root 3 over square root 3 is 1. And now when we multiply across, we get 2 square root of 3 over 3, because the square root of 3 times square root of 3 is you got your 3. And so now the cosecant of 30 degrees is, oh, sorry, this was x. Ooh, thank God I caught that. Oops, secant is over x with a cosine. Ooh, that would be embarrassing. My apologies. Is the cosecant, that is the reciprocal of sine, so r over y. And so sine is 1/2, so we're going to go 1 over 1/2. So we have basically 1 over 1. Oh, getting sloppy. My apologies. 1 over 1 divided by 1/2. So flip and multiply. You get 1 over 1 times 2 over 1, which is just 2. So I flip, boop. So there's my 2 over 1, and here's my 1 over 1 that stays there. Here's my denominator flipped. Oh. And finally, cotangent of 30 degrees is, let's see, now this one, rather than working with this, I'd rather work with this. These are the same, right? But once I flip and multiply 1 divided by square root 3, I won't have to rationalize. I won't have to rationalize because that'll be in the numerator. So if I have x over y, right, and that's going to be here, 2 square root 3 over 2 over 1/2. So I have square root 3 over 2, then times 2 over 1. These cancel out, I get square root 3, right? So I could, here I'm doing it by definition, versus here if I just flipped, because I know that cotangent is the reciprocal of tangent, and I know that tangent at 30 degrees is 1 over square root 3, the reciprocal would be 1 over square root 3, which when you flip and multiply, you'll get square root 3. Right. So of course you're going to get the same answer. It says here I did it by definition, here I did it by working with the result of tangent 30. Right? So there's your 6 trig functions of that angle, negative 2,850. Thanks so much for listening.